good thing. And robots build a while. I've been, using other people's designs, building other people's robots, using other people's robots just in general, using Boston Dynamics Spot quite a bit and some others. And, I thought, hey, it's time to build another one. This one I'm going to use for my own purposes in order to go upstairs to my office and collect 3D prints, because I will be having knee surgery and I won't be able to walk up to my office for a few weeks. So I wanted to put my money where my mouth is and actually build a robot that can actually go up and do that for me. So it's going to have to go up some stairs. It's going to have to open a door and collect a 3D print. And it might be something that I do completely teleoperated, but it's gonna have to do something like the ability to open a door. And so I went on to SORA and said to SORA, hey, what's a good robot with some descriptions of what it should do. And SORA came out with this, which I think it's a pretty cool design. I like the probably LED screen here for some visuals of emotions, kind of humanize the robot a little bit, and also like the touch screen here, and then the kind of white background, for the kind of body parts of the robot. And then, in thinking about it, I also asked SORA to say, hey, like, okay, what's some other ways we can do this? Like, could we maybe put tank treads on the bottom of the robot? Obviously, this does not need tank treads if it also has limbs, but the idea was sound. I like the coloring here, and like the fact that it has hands and fingers. And the next one, which I think is even super interesting, is this one has, as you can see, I'll run it again, it has these linear actuators here, and it looks like it is it's kind of like a Segway where it's a balancing robot. Balancing robots are cool, but ultimately unsafe for a home, because if the batteries die or whatever might happen here, the robot now becomes a falling dangerous object, either falling forwards or backwards. We don't want any of that. So if I built something like this, it would certainly have something for stability in the back, keep it from falling over, so that's another robot to think about. The cool part about this one is that I can use these linear actuators here to convey some kinds of motions, moving back and forth, like a hip movement. And then also, obviously, the idea is we want the robot to extend itself so it can reach higher areas and then compact itself when it doesn't have to. Another interesting thing about here, this robot would be its waist action. The waist movement would be here in this area, and then it would have to fold over to do things like reach the ground, etc. What we're trying to do is keep the movements compact so that the robot doesn't need to be bigger when it doesn't have to be. Bigger is better in a home. The other thing we want is to be able to traverse the spaces that humans can traverse. So that's another important part about this robot. Here's another one from SORA. What I like about this one, for whatever reason, even if I say don't give me legs, it gives me legs anyway. But and I said explicitly, do not give me legs, and what it does is something weird. But as you can see here, it's got the touchscreen. It has a unique shaped head. I like the head. These I always struggle with designing kind of after effects of the robot. Like if I, put the cameras inside of the head, then I'm just like, okay, now I need to model a head. And then it's really kind of annoying. But ultimately, this is a great design, and you can see here, I just kind of let this run in a loop because I thought this is probably at least the upper half, the kind of design that I would go with if I decided to build this thing all the way out. Putting DOF cameras in here, so I can detect speakers and microphones, so I can detect where the sound's coming from, cameras as well, and then several degrees of freedom up in the head so that the head can move. So in the spirit of that, decided to look at a motion study for a home robot. So in the past, let me turn off the sound on this one. That's really annoying. In the past, here, no sound off. In the past, I've developed these motion studies when I was going to build a robot, and essentially what they are, as I'm designing my next robot, I wanted to understand, how the motions would happen on the robot, where the center of mass needs to be, and do things like climb up stairs. Like this one had a rocker arm on it, on the wheelbase, and really kind of difficult to position the robot with a high mass on the upper half of the robot. As it went upstairs, it needed to basically be statically stable for the most part. If the batteries died, the robot would need to not fall down the stairs. So we had to figure out a way of making this happen. So I came up with this instead. This robot's a little bit simpler than the one you saw previously. It's got the arms from my friend Rob's Hope Junior robot. And here these boxes kind of represent where the tank treads will be. I'm going to use tank treads to get up and down the stairs. And I'm planning on building this one in a modular fashion. So if you think of this other one here, and then you kind of fast forward here, what we're seeing is a motion study in where I'm kind of looking at, okay, how much space is this robot going to take up? So this is about 2 feet 3 inches, somewhere around 2 feet. These are wheels that I would actually use. These are O-Drive hub wheels, and this is kind of, and there's no guarantee that the robot's going to face in this direction. I have this is probably behind the robot. I have the head and everything kind of in the opposite direction, but this is probably be the rear of the robot, and then there's no guarantee that I'll keep the head up here, because I probably want to take the camera and move the camera up and down with the arms. It's the easiest for transformations and figuring out how to grasp something in a distance with the camera. It's much easier when the camera is moving in the system with the arms. So that's something that might change as I'm doing this. And you can see here, in doing these motion studies, here's the whole thing moving around. I iterate on this quite a bit. So it's easiest to iterate on the motion study versus to iterate on the actual robot and its components. So if I start to bring in things like, extrusions and nuts and bolts and all those kinds of things, then this gets infinitely more complex. If I decide to move one small thing around, then everything has to move. So if you want to know my method of my madness, is I start with some components that I know I need. Like I know I need these wheels. I know I need the caster wheel, whether it's going to be in the front and the back or nose. I know there's going to be a LiDAR. Just for now, I'm using LiDARs for the kind of navigation, and these other cameras for other things. And I know I want this robot to kind of move up and down, like you see here. Obviously the whole system would need to move. So, I would go off and ensure that the whole system moves appropriately. But as you can see, that's the idea, as I want the robot to be able to move up and down. And so in effort to do all that, and really the other thing that you want to make sure is that the robot's not going to hit itself for the most part. And so, this is kind of what the kind of area that I'm giving myself to work with for this robot. This robot arm has already been decided. It's going to be the Hope Junior arm by my friend Rob. So this is the arm from Rob. And then, the other parts of the robot are, some that I am, making up as I go. So here's the screen, things like that. LiDAR, O-drive, because I'm used to working with O-drives, but I can go ahead and obviously create my own brushless motor system. Just this happens to be the fastest way of approaching my goal. I know the system's going to work because there's a whole group of people working on the O-drive at the moment. So I know that part's going to work. So I know this is going to work because there's a whole group working on this robot arm. And there's the main developer designer is a person who has a YouTube videos fully describing how to build these. His name is Rob from the Robot Studio. Amazing person has decided to open source his designs. And what you can see is if you follow Rob, as you get the entirety of these robot builds all together. We turn the sound off and kind of go over to his site so you can see. These are the hands that he builds, etc. Fingers, arms, all these things. These are his builds of, this is the Hope Junior arm right there. And someone's actually already printed it and brought it to a showcase. And actually, I think I have a video of this, of them teleoperating with a Meta XR device. So you can see this is just a great community is already being built around this. This person's already completed an arm. It looks like he's got it now working with, looks like it's holding a drill here. That's pretty cool. Solved the wiring issue that he had. But this is a giant community that's already working on this arm. So here's one. Somebody got that arm already working. So I know the arm works, and there's a huge community, working on that kind of thing. So if if I'm trying to do this in 2 or 3 months, the way to do it is to create situations that are easy for yourself. And number one is don't do anything new. For me, the bottom, the base of the robot isn't new. It's going to be modular and something that I've already done several times. The tank treads aren't new, but then it's something I can layer on at the end. I'm also going to make that modular as well, so you'll be able to add the tank treads or take them off and make it a not stair climbing robot. For me, it has to be stair climbing because of what I'm trying to accomplish. Because I'm trying to do this in about 84 days, a lot of things need to have come together automatically. So I've already designed the tank treads. I've already ordered part of the parts there. I already have the LiDARs. Already have the O-drive wheels. Like I said, the arm is completely designed by someone else with a giant community. The touchscreen is something that I already have. The camera I'm going to use is Luxonis OAK Pro. I love them. I use them all the time. Microcontrollers will, be as needed. But I source a few things from Waveshare that I use quite a bit. And like I said, the arm is fully defined. So this is actually not that hard of a project from a hardware build perspective. The part of this project that's actually not difficult, it's actually not even difficult, is the software perspective. But to create a really, really accurate URDF file, this is going to be going upstairs. So for me, the URDF file has to be really, really accurate. So while we're going through this robot series, I am going to really, really hyper focus on making sure the URDF file is correct, because it's going to be used again to go upstairs. So with that, motion study is complete for the most part. There will be another joint here that I'll work on, because the robot does, while I don't want the robot to bend in this position, I am going to have it bend slightly. There will be a bit of pivoting in this motion, kind of, and the reason for that is when the tank treads do happen, and it's going up and down stairs. What I want is to have the center of mass to kind of move in accordance with the tank treads going up. And I think I don't have a video prepared for that, but I can easily find one that kind of demonstrates the activity that I'm trying to convey. So if you bear with me for just a second, I'll find a video that can help us out here. Here's one. So, not to steal from any YouTube creators, but this is the idea of what I want to happen as the robot's going up the stairs. You know, I want the tank treads to take over. In my particular case, yeah, I understand why they have that back set of wheels in there, but really what I want is the balancing act. And because there's not a person on top, it does not need to be completely 100% level going down the stairs to kind of make the person happy. This is more about the robot being happy going down the stairs. And I wanted to, if for whatever reason power went out, I want the robot to either be stuck on the stairs, or I want the robot to slowly roll down the stairs in a comfortable position, you know, using kind of natural braking or even secondary braking system. But as you can see, this is not something that hasn't been done before. It's kind of not brand new. So you know, there you have it, the entirety of what I plan on building. And just to take you back to that, you know, kind of original, we're gonna get to something like this in probably 2.5 months. Won't be as pretty as this, but as you saw, you know, we'll have the majority of the bones of this kind of thing in about 2.5 months. I hope you stick along for the journey, and we'll get started with some actual CAD design, and with the first set of CAD models, we'll turn that into a URDF. If you're following my you know, kind of basics of ROS tutorial, then you'll get that. And then if you're also following my Isaac Sim tutorials, you'll also get some Isaac Sim goodnesses in there as well. Thank you for watching, and I hope you all have a great day.